So, welcome to Ask Jerry and Ray Anything About IBM Z. This week, we're going to continue our study of what is JCL. And Ray's going to get us started.
Yep. So, continuing on from where we were last time, we're going to talk over the vital importance of JCL in mainframe operations. So this is kind of the next step up from talking about individual users submitting their jobs and whatnot to how the organization uses it. Next slide. Yeah. There we go. So in some organizations, especially large financial institutions, you can have well over 100,000 JCL jobs running per day. A lot of these are confined to your overnight batch window so that there's very minimal interactions from different users who might potentially change some data. So you have your end of the night settlements, account updates, things like that. And so financial institutions are probably some of the biggest users of JCL and mainframes in general, but as we've said before, almost every industry uses it. Manufacturing, logistics, retail, everybody. So we're going to kind of continue down now into why everything relies on JCL. And so, again, batch processing, online transactions, your TSO users, and even some cloud interactions rely on JCL. As cloud is advancing more and more into organizations, IBM has been evolving the back end for storage so that cloud access is a lot easier, and it can now be done in JCL as a DD card instead of something that had to be, very meticulously set up. Yeah, there are some things that have to be set up for access, but at the same time, they're making it easier, which just goes to show that, the mainframe is evolving. It's still keeping current with the times, and it does embrace other platforms. As they say, the right tool for the right job. Mainframes are great at certain things, but sometimes cloud is better. So in the organization, though, again, as we were talking, automation. Popped my thumb, and for some reason I just blanked on it. So JCL and automation kind of go hand in hand. The overnight batch processing, right? Nobody's sitting there submitting each job individually. There is an automation suite that sits there on the system, and it submits the jobs, it checks the return codes, and depending on how your decision trees are set up, if a previous job fails, it might not submit the next job in the sequence, whereas some are more fault tolerant than others, and so they just rip them out regardless of what the previous job's return code was. And so that's how you get your automation into the system. But the good thing about that, though, is it's in the system. If you want to change the job, you can scale it up to something that, as a job's boundaries expand, right? Everything's getting bigger, everything's using more data. All you have to do is just tweak the JCL a little bit, and there's no changes to automation needed. It just keeps on running. You might have to check that it doesn't run longer than you expect, because sometimes the automation does look at how long a job is running and starts raising flags if it runs for too long. So as data scales, you do want to keep that in mind, that jobs might run longer and your batch window might expand, right? So as you're growing your batch window, you might start running out of that overnight window and into when people are logging in for the day. So either you have to cut it down and run things in parallel, or move things back a little bit further in your batch window. Again, resource optimization is a great way that JCL handles things. The system sees that the job needs X resources. If they're available, it'll swap the job in, it'll do some processing, swap back and forth between jobs as maybe resource contentions arise, but then as those free up, the job continues. And so that allows things to run continuously and pretty much effectively. Once you put it in, very few changes are needed. So, in the end, JCL is the backbone of organizations that run on the mainframe. You can do, you have your job orchestration. Some jobs even kick off other jobs within it. So, it doesn't necessarily have to be an automation suite that does that. You just have to, know how to do certain things in your JCL. You get precise control over your storage, over your other resources. The mainframe has reliable I/O. That is one of the big three things that the mainframe touts, is reliability. And so you have these high performance channels going between your CPU and your storage. And sometimes, depending on your backup situation, your storage can be replicating locally and hundreds, if not thousands of miles away. And it all gets written correctly and reliably. And all of that, builds up into your operational efficiency, where they try to tout the 7 nines of operational efficiency, where, the system has only 0.00001% downtime in a year, which I think, what's that, Jerry, like 15 seconds out of an entire year, something like that. It is a ridiculously small number.
All right, I'll take over from here. So we've talked a lot about JCL, about how effective it is, how important it is, but we haven't really talked about what you as a user has to do with it. So we're going to look at defining a job in JCL. And so these robots are building some JCL. It's got a job name, it's got an execute card, it's got some DD statements. And we haven't discussed in detail what those are, but we're going to do that now. So first, JCL is job control language, but what is a job? Well, here's the Webster definition. A job on a mainframe computer refers to a specific task or set of tasks that the system processes. These jobs are crucial for large organizations and typically involve handling significant amounts of data and transactions. So basically, it's how you tell the system, it's what you tell the system you want it to do. You put it all together and you submit it to the system. The system says, oh, Jerry has a job for me. It takes it and it processes it. If you've got multiple steps, it runs through all the steps. You can say, I don't want to run this step if the condition code is not 0. Then it won't run that step. You got all kinds of controls, and we'll touch on those today. And so they can do bulk data processing. This is a large amount of data. It can also do transaction processing. There's something called CICS, and this is your online system that Ray was talking about. So you do your batch processing overnight. People roll in at 6, 5, 7 o'clock in the morning. And notice I didn't say 6, 7, but they have tasks that they have to do. He talked about setting up the loading of the trucks. They've got to get all that done. They have to have the online system available to do that. So the batch window has to end on time so they can get all their work done. Um, Actually, when you go and approach an ATM machine, you're doing a transaction that probably ends up in somebody's mainframe somewhere. And then it also runs critical applications. So you have your business functions like payroll, billing, inventory management, accounts payable, accounts receivable. All those business functions are taken care of by JCL and jobs that are run in JCL. So we've mentioned the job statement. What the job statement is, it says, okay, this is my job. Sometimes you give accounting information so they can charge back to particular divisions within the company. Um, and it tells all of this information in that job card. You can tell it the class that you want it to run in. You can tell it the region size you want. All of that specified in the job card. Then you have execute cards. Notice I'm saying cards because I'm old and probably ancient at this point in time. When I first started, we actually had card decks, and you had physical cards that you would, get key punch operators to key up for you. You take those cards, you give them to the system, and it would run your job. So now we call them statements, but they're still in my mind cards. But you
I've
have
personally
exact.
never seen an actual card,
don't
but
don't rub it
I
in.
well, the vernacular still persists, right? I still call it a job card and an exec card. So yeah, maybe someday it'll change.
But the exact statement, this tells the system, okay, I want to run this program or I want to run this proc. Now, a proc is a bundled set of JCL. It can have multiple steps, and you tell it, I want to run this program, and then I want to run this program, and then I want to run this program. You tell it within a procedure or a proc what you want it to run. Or your JCL can just say, I want to run this program. So today we're going to take a look at both of those instances. Once when you run a proc and several times when you run programs. And then you have DD statements. Now the DD statements are data definitions. So they tell the system, okay, this program is going to have to do some work on some data. So here are the statements that define what that data is. So you give it a DD name, and that's what your programs are going to be looking for. And then it will go and you tell it where the data set lives, what type of unit it's on, the size of it. You give it all that kind of information on the DD statement. The system knows what to do with that, and off it goes. All right. So, what good is talking about JCL at such a high level without giving you some real world examples? So, uh, this is a job card. The job name is job name. And, I give it like you can tell it the programmer's name. You can tell it where you want the output from the job, the system level output. You can tell it where you want it to go. That's what the message class is for. The class tells it what class you want it to run in. And we haven't really talked about JES in depth yet, but JES has initiators. Initiators can handle specific classes. And so my job will find its way into an initiator that runs class A jobs and then run my job. When this job ends, I wanted to send a message to my user ID telling me that this job has ended. Whether it's successfully or ab-ended, it'll tell me whether that job has run. Now, the exact statement for this one is you're executing program IEF 14. So I had a fairly inexperienced developer ask me, so what does IEF 14 do? And I told them nothing. But actually, it does do something. It sets the condition code and returns back to the system. So that our BR14 is a similar language instruction that says go back to whoever called me. In this case, the system called it, so it sets the return code and goes back to the system. So this job would run. It wouldn't do anything because there are no DD statements, but it would run. So this is your basic, the simplest JCL you can have. It has a job card, an execute card, and that's it. Then we get a little fancier. Now this job has a DD statement, and it doesn't matter what DD name you give to this DD statement. IFBR 14 is never going to open that data set. But what you can do is you can allocate a data set using this JCL. Understand that the JCL predates ISPF, all of your online systems. It was the only way that you had to communicate with the system. So if you wanted to allocate a data set, you couldn't get it on your ISPF system and go and allocate a data set. No, you had to run a job, and this job, IFBR 14, would allocate this data set. This data set's name is jerry.test.data. I told it it's a new data set. The fact that I gave it a comma first says take the default. The default for disposition is new. So I could have specified new comma catalog, and it would have known that it was a new data set. The comma does the exact same thing. And since I'm such a non-great typist, if I don't have to type it, I can't mess it up. So it's going to catalog this data set. It's going to put it on DASD, since I said unit equals sysall DA. I told it how much space I might need, and I told it some information so that it would make the right kind of data set. That's what my DCB statement does. Sets it up in the right format so that the program that I will use it in later on is happy. All right, so now we're getting a little bit deeper. Here we have two steps in our job. The name of the first step is step one. The name of the second one is step two. Now, I never mentioned comments before, but / asterisk tells the system, okay, you don't have to do anything else with the rest of this. This is a comment. This is for human beings. It's not for the mainframe to do anything with. Now, at the end, you'll see that I have a / statement, and the / says, this is the end of this job. Now, if you submit this job from TSO, it says, okay, fine, here's the end of the job. Um, you don't have to have that. And when it gets through reading your statements, it says, oh, I don't see any more statements. This must be the end of the job. So you can either have the / or not. Either way, the system will know when it comes to the end of your job. This becomes relevant, however, if you want to have multiple jobs within the same data set. You could submit 5 jobs, and when it came to the end of one and came to the job statement for the next one, it would know that it was at the end of the first job. Similarly, if you have the // it'll know it's come to the end of the job. Now, what that / can do is it can stop you unexpectedly. If you have a / in the middle of the JCL, like up here where this is a comment is, the system won't complain, but it'll stop and it'll never execute step two. So that's just something to keep your eye on. We also introduced DD dummy. Now, program IBGenner requires a sysn DD statement, but in this instance, I don't have anything to tell it to do. That's why I give IBGenner, which is an IBM utility. And as you go further into the mainframe, you'll see a IB copy, some IEH utilities. IBM has a ton of utilities to do things for you. Remembering that all of this existed before you had online terminals that you could do things on. And so and with IBGenner, you can go to the sysnd statement and tell it some specific instructions. Well, this is a very straightforward job. I want to oh, and my JCL is wrong. It would cuss me out because I gave it, I told it it was a shared data set, or sysut2, but actually it should be a new data set. And so when it went and it ran up on this one, it might allocate it unless it was SMS, and we don't know anything about SMS yet. But if someone ever asks a question, we can talk about that. But it'll copy whatever's in sysut1 and put it in sysut2. And since I don't have any instructions for IBGenner, I just said dummy. And it says, okay, I'll see this DD statement. I'll open it and get an immediate end of file I'm done. I'm happy. Life is good. And then I've got another step in this job that executes IBGener again for another set of data sets. So that's step one and step two. This is a multiple step job. And then we move on to get a little more fancy. This is a proc that will execute TSO. Now, how do I know it's TSO? Well, IKJEFT01, that is the name of the program that is TSO. So when I see that, I say, aha, this is a TSO proc. Now, it has some parameters in it. So you say root, and then when you want to reference that parameter, you have to say ampersand root. And down here with this IZUSRVMP DD statement, we use that ampersand root. So it will plug this in the place of the ampersand root. Similarly, we have a, how's that part? Okay, so that's the only parameter that we have. Export is one of the fancy new DD statements. Similarly, set is one of the new DD statements. And we won't go into that. We're going to stick to basics. But later on, if somebody asks us, oh, well, what are these fancy JCL parameters? We can talk about those. So this is a TSO proc. This is what you get when you log into TSO. It goes out and logs you in and allocates these data sets, and then goes to your terminal and lets you do whatever it is that you decide you want to do in TSO.
And using procs when you're submitting JCL to the system to run a job is nice because you can parameterize things, and so you only have to change it in one location. And if you use the same data set name in 7 different places, you don't have to worry about making 7 different changes. You just change the parameter once and submit it, and it makes sure it's can use it everywhere.
Very good. Good point. All right. Now, that was a proc. Now, this is the proc that runs CICS that we talked about earlier. So we started out with a statement with a job that had 2 statements. It had a job statement and an exec statement. This CICS proc has probably on the order of 50, 60 lines in it. But I just wanted you to see you can start off simple and then you can go and get very, very complicated. And this is a multi-step proc. It's got a whole bunch of parameters, and it seems like it goes on and on and on and on. But all of this is the proc. The system will see it. When you start CICS, it'll go find this proc and execute those statements. The actual CICS step itself sits there and lets users enter all of the various transactions they need to enter. And at some point in time, they say, okay, CICS, I want you to end. CICS will end, it will go down, and then there are some steps that run after CICS has run. But we had one with 2 steps. I'm sorry, 2 DD statements. This one has 60, 70, 100. I didn't take the time to count them, but if you want to know, just ask me and I'll tell you how many statements it actually has. All right, so that's the end of our session for today. And come back next week and we'll talk some more about JCL and allowing you to run JCL on your PC. So don't miss out on that. And we'll see you then.